Okay, so now we're going to talk about continuous manufacturing process. This is the definition from Wikipedia, which I think is excellent. And the continuous process is one where you always have material flowing. That's kind of the definition. Now, in many manufacturing plants, you don't necessarily have the entire plant being continuous. In many manufacturing plants, you might have some section of the plant being continuous. And that we're going to look at for some portions of that. But generally speaking, many continuous plants run 24/7, 24 hours a day, 7 days a week. And the reason for that is because the expense of shutting down, cleaning out, and doing a changeover is very high. Now, the example I'm going to give you is going to be petrochemicals, gasoline. Now, this is a presentation, a diagram that comes out of Wikipedia as well, to give them credit. And we're going to follow through this to see how you can actually crack crude oil and convert it to a variety of useful products and some also byproducts. The purpose of this entire line is it runs continuously. So if I go down through here, we start off with top left corner, crude oil coming in from a vast reservoir, usually a giant tank, pumped into this process where it gets warmed up, and then it gets through what's called a hot product or pump around. In other words, I can tap the crude oil to get some portions of that crude oil at the high density or low density realm and make use of those products. Or I can just pump around those taps. That gives me alternate paths for that crude oil, but it's still always running. I then mix that crude oil a little bit with water, and that water picks up any of the salts that's in that crude oil. And then we have a desalter that takes that salt off in the form of brine, and the resulting crude oil without any salts ends up in another section where you can take off additional hot products or pump around, alternate paths. And don't ask me what these products are. At this point, I don't know what the products are. It then takes the desalted crude oil, heats it up to 398 degrees C, really hot, and puts it into the crude oil distillation tower. And that tower then can continually tap off at a variety of levels to get a variety of products. And I'm not going to go into the details of how that tower works, but continuously at any time, they can open and close these valves to get more or less of the following products. They can get kerosene or jet fuel if they have a higher quality kerosene. They can get light gas oil like they would use for heating gas. They can get heavy gas oil. They can also get residue fuel oil. So there's a lot of different kind of material you can take off of that process. Off the very top, we can get something called naphtha, which is a different product. And there's a couple other processes that go along the side of this. But this is the essence of how we crack crude oil into the various kinds of lighter oils, lighter gases that are then used in all sorts of heating, automotive, and other applications, including jet fuel. It's continually running. There's always some product coming out somewhere. They may get more or less of one product versus another, depending on some market decisions. But the thing is always running, because once you let a crude oil distillation tower cool down, or let any of these lines cool down, the clean out is extremely expensive. They may only do clean outs and change outs and repairs once every year, or once every 3 or 5 years. So it's an incredibly expensive process to let these shut down.
So is computer chip manufacturing continuous? Because I know to slow them down is very, very, very expensive. Like, I believe the one in Israel only closes down like 1 day a year, and it costs them millions.
It depends on what portion of the process you're talking about. In general, if you look at the entire process end to end, no, it's very much discrete at the back end. On the front end, I believe as part of the silicon wafer process, they need to run that continuously. But I don't know enough details about why to give you a good reason why. But I would say end to end, the answer is no. But yes, at the front end, there are some key reasons why you might want to run that continuously. Also, a lot of people don't want to shut down because it's really expensive to not produce products when they're in high demand. So they'll keep running a manufacturing line with some partial shutdowns for one machine or another machine or another machine.
Okay, cool. Thank you.
That sounds like a good research project. Thank you, Harrison. So steel manufacturing is the example of another continuous process. And what I'm going to do is share my screen here. We're going to go look at that video. If I can pull it up here. All right, so sharing my screen. And we're going to skip the ad.
When a very standardized product is needed in very large volumes, a continuous process is the best type of manufacturing to use. At this Nucor steel plant in Crawfordsville, Indiana, which produces 1 million tons of steel annually, the product is produced continuously. In fact, this plant was designed for the specific purpose of producing a large volume of standardized goods in the most cost-effective manner possible.
And that's the key point with continuous, a large volume of standardized goods in the most cost-effective process possible. And that's why we choose a continuous process.
Since the end product is very standardized, each piece of equipment performs a specific function and is rarely, if ever, modified for special needs. This roll housing, for example, weighs 130 metric tons and is welded into position. And this ladle, which holds the liquid steel before it's poured into the mold, has a capacity of 112 metric tons. As the name continuous process implies, there is little need to stop production during the manufacturing process. In fact, while the plant is rolling thin slabs of steel at one end of the plant, more liquid steel is being prepared for casting at the other end. The result is a manufacturing process that uses very rigid equipment to produce a large volume of a single product.
So that is.
Try this strange 10-second tech.
Oh, that's weird. I'm not sure why I'm looking at somebody's internal organs there. YouTube is so fun. But yeah, that essentially is the definition of continuous. However, we're also going to take a look at UTS. Now, UTS is also a continuous process, but they are in this realm of food manufacturing that's almost like repetitive because it's producing continuous chips that then get salted and seasoned and then bagged and packaged. So it's a continuous process of chip manufacturing where you always have potatoes running in one side and then chips running out the other. So let's take a look at the let's look at the UTS factory tour. As I try not to look at YouTube's thing here. All right.
I'm here at the Woods factory, which has been here in Pennsylvania for over 100 years. It actually just went public last year on the New York Stock Exchange, but it's really fun. They've got a self-guided tour here. You can go through your own pace and see the whole process of making their potato chips and snacks. Right here, you've got where the potatoes come in, they're washed and peeled.
So watch this. This is a continuous process. Potatoes constantly being added in on one end, washed and peeled automatically with machinery, and then roll into the slicer.
And then after being peeled, they're brought over here and cut into chips. And I'll show some close-ups of all that. Then they go through a dryer. So out of the chipper into a dryer. Then we see them go through this fryer, and it takes, I think, a little over a minute, maybe 2 minutes to fry them. They come out here, then they're salted, and after salting, they're brought over to this room where this machine is looking for dark potatoes, and the darkness, I guess, is caused when the potatoes are exposed to sunlight. They produce more sugar.
So if you think about it, a machine looking for dark potato chips, that would have to involve some form of a vision system. Now, it might be a very simplistic one with a black, white, or a dark white sensor, but this is a kind of a vision system and also extremely high tech. Obviously, we didn't talk about the manufacturing steps, but I assume that chipper is fully automated. I'm assuming that there is extremely fine temperature control on the oil temperature. So we've got all sorts of heating systems for that oil, and all of those are part of a continuous process. And when I say temperature control for heating, that means we have a sensor and then a control mechanism. And the sensor would give data to a small computer, and that small computer then would figure out how much additional heat needs to be added to maintain that oil bath at the right temperature to make the perfect Utz potato chip.
And so it turns dark when they're fried. So this machine sorts out all of those and gets rid of them. They go to feed animals. Then up here, they're seasoned and packaged. So right over here is the seasoning, and then the packaging down beneath.
So at this point in the manufacturing line, in those giant seasoning rolls, or the giant spinning rolls that spun seasoning into the chips, make sure the seasoning gets into all the nooks and crannies. And then it dumps into a chute, which ends up in a packaging line. So then those certain quantities of chips are weighed out, sealed into packages. And here, the packages then get put into boxes and shipped. Now, this is interesting to me. This shows people putting all those packages into areas where they're going to be loaded into boxes with the right quantities. But that's not where Utz has stayed. Utz has actually gone an automation portion of that. So as part of the continuous and batch processing, today I'm going to end up with how Utz does its robots to do that, which I've got a link to. Hold on. Let me dive into the Utz robots. There we go. Finally found the right video. So let's watch how Utz deals with packaging on some of the more advanced lines.
Utz's variety pack robot machine. Here, robots pick up and put the bags in the appropriate position according to the recipes called for. We can see the robots pick up, align, and drop off bags in the right positions.
So
Then
the robot then
the
finishes packing these into the right order. And then from there, it goes into a conveyor,
Will be dispensed into boxes,
which dumps them into boxes.
boxes of
So I want to mention a few things here about this robot line. Obviously, we see how it was kind of replacing people. But what do you notice about that robot speed? And I'm going to stop my video here. What I'm going to mention here is that